Welcome back to the channel. Hope everybody's doing well, and in today's video we are taking a look at this VDE torque handle from Wiha. This is from their Torque Vario range, the 2933 series. Actual part number on this is 431778, and it is a 5 to 14 Newton meter torque wrench with plus or minus 6% tolerance. So this torque T-handle is the next step up from their Torque Vario screwdriver. So I have here the screwdriver that I had for many a year. It has a 0.8 to 5 Newton meter range, again plus or minus 6%. Obviously this then goes from that 5 Newton meter, it picks up at 5 Newton meter and takes it up to the 14 Newton meter. Wiha do a 5 to 25 Newton meter 1/4 inch drive torque wrench as an alternative to this. It obviously gives you an extended range, however it is incredibly expensive. I just didn't want to pay that much at this moment in time because this little unit on its own does set you back £180, and this is what you get. You just get a little case that comes in, a little sleeve case similar to the screwdriver. You do get a calibration certificate, average of 6 measurements over 5 Newton meter, curiously an 8.4 Newton meter setting and a 14 Newton meter setting. We'll see how close we can get to them on my Ghidorah testers. And then obviously you have the T-handle itself, and then the adjusting tool, which is not the same adjusting tool as for the screwdriver. Before anybody asks, this is the screwdriver one, quite a bit smaller, it's hollow for the T-handle there, so you can see they are completely different. Unfortunately, you would have thought that they would have made them the same, wouldn't you? So that's what you get in the kit for your £180. On the little card inside the sleeve you can see you can get some bit adapters as well in torques from T15, T20, T25, T27, T30 and T40, hexes 3, 4, 5 and 6, and then nut spinners 7, 8, 9, 10, 13 and 17 down there. That's just the range that you get for this T-handle. You also get this little 1/4 inch drive adapter, and as I said, I've got a fair bit of Wiha VDE stuff already, and I have a set of 1/4 inch drive sockets, so it makes sense for me to go down this route rather than pick up individual bits. Individual bits are in the region of £10 to £20, but they do seem a little bit awkward to get hold of in the UK. This 1/4 inch square drive adapter, that is £11, and it's actually part number 2837992. It seems to be a bit more easy to get hold of as well. So that's our basic. It is VDE, rated to 1000 volts. You can see the VDE symbols on there. I have checked, there is a VDE certificate on the website available for this torque handle to verify that against. Now in terms of what you would actually use this for on our sites, for me, if I'm dealing with contactors, a ABB contactor AF116, which is around about 55 kilowatts, will use an 8 to 9 Newton meter torque setting. So when you step up to that 55 kilowatts and above, then you'll start getting beyond the 5 Newton meter and the torque setting of the screwdriver that I have. I also have battery systems that I work on. Battery systems with an M6 stud, you're okay, I can do that with a screwdriver. With an M8 stud, that's actually a 10 Newton meter setting. So again, I would need this rather than the screwdriver that I've got. So that's my reason to buy that with. So what we'll do is we'll pull our little Dremel tests forward and we'll see how good we are at doing the settings. To actually set this, you don't set it from individual inside there, you set it from the end here. They do show you removing it with a coin, but a Phillips screwdriver will also remove the cap as well. So, but yeah, there's probably a good reason this is going to get lost, I would imagine, over time. And then you just insert into there, line it up, and then you can see through the window, hopefully. Not sure how well. You can then start to adjust this, and you can change the setting. The setting adjustment is completely smooth. There are no clicks, Nothing to give you any idea that you've hit a different setting other than the little window there and the alignment mark in there. That's the only way you can do that. So I don't know how I've seen that. I'll set that to 5 Newton meters there. And then we need to put our bit adapter in. Our bit adapters are unique. Again, not sure how well you can see. There is actually a drive pin inside there, as well as the hex drive, a bit like a security Torx bit. And you can see the hole in the end of the drive there. So you have to use VHA's bits to utilise with it, and it just snaps in place like that. We use our 0.9 to 55 Newton meter unit, as that is more applicable. Put a socket straight on there, and we'll reset our camera so that you can see the screen a wee bit better. So that's that in there. We are set to 5 Newton meters, and we will give this a clip round. 5.4, 5.3, 5.55, so there's 3 clicks there. Our 6% plus or minus 6% should be between 4.7 and 5.3 Newton meters, so you can see they all read high, unfortunately. I cannot replicate the test certificate which said 5.015 Newton meter average over the 6 tests that they did. And we'll move it on. So 8.4 Newton meters again. I'm not sure how well I'm going to be able to show this to you. You can swing this around. It might be that this is might have to take some pictures. Up to 6.5 Newton meter, and then it shows to 7. And then it goes to 8 Newton meter, and then we are on to 9. Now the problem is there is no 0.5 in there, so how you set this up to 8.4 with any consistency I do not know. We've got 9 there, we take it back, we'll set it just so that the 8 Newton meter is showing just there. Again, I don't know how well you'll be able to see that. I'll perhaps have to take some pictures, and then we'll see how well we can do this time with the 8 Newton meter. 8.65 is a little bit high, but we should be 7.9 to 8.9. So it is in spec. 8.54 is in spec. 8.51 is in spec again, so that's all good. 8.4 Newton meters. We'll take this all the way up to 14 Newton meters. Which is just there, and then we'll try again. And we are 13.68, we are 13.857 was their findings. 13.61 again, so fairly consistent, and we should be between 13.16 and 14.84, so that is in tolerance as well. We'll just take this back to the 5 Newton meter mark again, and I'll show you that on this tester, then I'll bring in the smaller tester. So that's our 5 Newton meter, and we'll just show you on here. 5.39. I'll just push him to one side and bring in, so you can see that there. And this is, I need to change the bit over. This is a slightly different drive. I'll just show you on this one as well. 5.4, so comparable reading really. 5.37, so they are all out of spec. So don't know why I can't get the 5 Newton meter to read, but it is what it is. I can only show you what I find, can't I? So I'll chuck them out of the way. Other than that, it's the usual VHA quality, fairly nice units. These are the 1/4" drive sockets that will just go straight on over there, and you've got yourself a little T handle there so no problems. It's all compatible with all their other kit. But there you have it. I'll leave you with the set of tables that I produced for this. This is 10 tests I do it over, and you will see it shows you what the findings were during the video. That 5 Newton meter is out of tolerance, too high, and then 8.4 Newton meter. I did get a bit better, the 8.4 Newton meter setting, and then 14 Newton meter was very similar to the test in actual fact. During that it was reading a little bit low during the tests on the video. But that'll be it for this video. Thanks very much for watching. Hope you found it useful, and I'll see you again in the next one.